Yeah, okay.
That's the good one, right?
Yeah, it's a good.
Okay.
All right, sorry. Okay. So first I want to explain what is a feature store. So essentially when data scientists, data engineers and so on work together to solve machine learning problems, the data engineers prepare the features, then they ship them over to the data scientist, and then the ML engineers bring those trained machine learning models in the end into production. So and then these production machine learning models have to consume live data from somewhere in the enterprise, which is usually happening more in a streaming fashion, or which has to happen fast. So there's a key value store somewhere that has the latest features, and then in the end this production model has to use these live features, and the live features have to be somehow synchronized with the training data the data engineer used in the beginning to create the features and so on. So this is like an organizational problem to keep consistency between training data and basically the data during live serving. And Feature Store is basically a platform, a solution to tackle this problem. And yeah, to make it easier for those different roles in data science who work together on building machine learning models, bringing them into production to make the collaboration easier. And so at Hopsworks we built this managed platform. It has like a nice user interface where people can work on collaboratively, and it has this like a Python and Java API integration that is made for data scientists, right? So you have SDK, which is pretty similar to what people are used to scikit-learn. Basically, this is almost the same as when you would use scikit-learn, but this is backed up by the Feature Store platform. And under the hood, it's essentially, or the central component is this synchronization between an offline warehouse, data warehouse where the training data is stored, and low latency online feature store, which serves the features to the production model. And the platform takes care of keeping the schemas in sync and keeping the latest version in the online feature store, and makes it easier to produce correct training data, also for training new model iterations. And we use DuckDB in the offline feature store. So, and that's the way it used to be. That's the way it is up until now still, but I'm going to talk about what our prototype solution based on DuckDB is. So what people do when they create a training data set from this data warehouse, they trigger a Spark job in our backend, and that Spark job does often point-in-time joins between a table with, let's say, your target entity, IDs you're interested in, some timestamp, and the label. Say some action happened, and that's the action you want to predict, and then you have some feature tables, and people want to basically join the feature tables with this label table and only use features from exactly the point in time where the label is from or earlier to prevent data leakage and so on. So that's what happens in this Spark job. It creates this training data set, and then they can consume it through JDBC or through REST call. They can basically get it into their client again. They use REST to get the training data sets. They can use JDBC to explore the sets of features that are in the backend. And yeah, that's why I wanted to have the slides. So the idea is to replace it because there's huge overhead from using Spark. And usually the data sets people use, as Jordan was referenced, like his experience at BigQuery, and we make the same experience. People usually have quite small data, and especially if you want to demo stuff, and then you say, oh, I have this small data set, and blah blah blah. When you start, and then the backend job keeps running for a minute and a half to return your 100 rows or so. That's a really frustrating user experience. So what we needed to get this done is we use Hoodie. It's also a lakehouse type of system. pretty similar to Iceberg or Delta. It has basically this Hive-style partition data and some extra metadata, which tells you which are the latest Parquet files inside of this Hive partition structure that represent the latest state of the data. And basically we just wrote a custom connector to that, or a custom layer on that, which basically tells DuckDB, or which tells DuckDB which ones are the latest Parquet files, and also some logic to push down filters, so we can filter out partitions which are not relevant for the query. And then we have this HopsFS. It's basically a Hopsworks version of Hadoop, of a Hadoop distributed file system. So it's compatible with the HFS readers from PyArrow. And since yesterday, actually, we can read with DuckDB directly from HFS, which is really nice because this allows us to use all the out-of-core capabilities of DuckDB. And I can show a little bit what that means. When you look at the tutorial I mentioned earlier, we have this tutorial here, which people can use in Google Colab or so. And if we just read feature group from there, table with 100,000 rows, it usually takes 8 seconds. Now with this new integration, it takes only 1 second, so a 7x speed up, and there's no query really executed in backend. It's just reading the Parquet file, and the speed up comes basically from streaming it with ArrowFlight instead of JDBC. And then is the creating training data set. That's the point in time join, where DuckDB really helps to speed it up. And the last one is reading the training data set. That used to be a REST call, but we can also use ArrowFlight to send the data over. We can even do this without necessarily having to save the data. We can just stream it directly from the training data set job back to the client if we would want to, because we can do the zero copy handover from DuckDB to ArrowFlight. Yeah, this makes the tutorial much faster. And so a little bit more benchmarking on this point in time, or as-off joins, which are really common. I know there are not even there's not a particular join type. This as-off join is still on the roadmap, as heard today, and so this is only using basically a construct which use argmax and some features that are already built in DuckDB. And in Spark we use just a bit of nasty join with window function, and this is not very nice for Spark. And if you look at the numbers here, you know, a lot of benchmarks that focus on this side, right, on the large scale factors, and just call them scale factors. It's like one data set with 1 million rows. But what we are most interested in is the left side, right, the 0.x scale factors, which you don't see that often. But there the speed up from using DuckDB to execute this join is quite substantial. But even with the bigger scale factors, we still have an edge over Spark using this. And yeah. So basically, the conclusion, DuckDB and ArrowFlight, they go very well together. We still need a custom extension to read data from Moody. We don't need really a custom extension anymore for reading from HFS. And yeah, the speedups are not only for small data, or not so small data. We can also query quite large data with DuckDB thanks to these out-of-core capabilities. And on top of that is also the potential to expand the use of DuckDB on the client side, to do some post-processing there. So overall, we're really excited about this technology and what it brings to our platform.